Namaskara students, welcome to We Karnataka KCT and Boards. I am Diksha Kaushal, your chemistry master teacher. So in today's lecture, we are going to see the top hot questions, that is high order thinking skills questions from your chemistry section midterm. So everyone, don't forget to like the video and also share this with your friends. So now let us start this without wasting any time. Let's see your first question, that is answer any of the following, right? So first is mention the major product formed in the following reaction, right? So first thing is here you are given with some alkyl halide, right? That means this R and X is given to you along with Mg and in the presence of dry ether. So when you have alkyl halide with Mg, you will have the formation of Grignard's reagent, that is RMGX. Now, as we can see, our alkyl part is your benzene ring. So here it will be benzene ring, and what is Mg? Mg is definitely Mg only, right? And what is halogen? Halogen is here Br, right? So that will become your product here, right? Next question is 2-bromopentane in alcoholic KOH. Now always remember, when you have aqueous KOH, then there will be substitution of bromo, that means bromine group, with the OH group. But if you have alcoholic KOH, there will be dehalohydrogenation. That means minus HX will be eliminated from this side, right? For example, 2-bromopentane. What is 2-bromopentane? We can say that 2-bromopentane, 1, 2, 3, 4, 5. 2-bromo means here you will have bromine. Right, here you have CH3, here you have CH, and this is your CH2. I'm just completing the tetravalencies here, right? This is your CH3. Now I know that one bromine will be eliminated from this side, right? But ma'am, this is the alpha position. Now from any of the beta position, the hydrogen will be eliminated. And according to Setzef rule, that product will be formed which is highly substituted, right? In which alkene is highly alkyl substituted. So if I say I want to make a product where this is your beta dash, if I want to eliminate hydrogen from beta position, the product will be C double bond C, CH3. So as you can see, this is your CH2, this is CH, right? And this is your CH2, right? So as you can see here, you have one alkyl substitution, right? There's not so many substitution, only this alkyl substitution is there, right? Okay, what about if I eliminate from beta dash position? From beta dash position, what you will have? You will have CH3 as it is, right? This is your C double bond C. Here you have elimination of beta, bromine. Here you have elimination of hydrogen, right, from beta dash. Then you have CH2, then you have CH3. So clearly this is more highly substituted, right? So that is why here this will be the major product. This will be the minor product, right? This will be the minor product. In the option, if these two are given to you, you will take this answer, right? Major product. Now, next is, third one is CH3I-NaI dry acetone. Now, this is a naming reaction, right? What is the name of the naming reaction? Finkelstein reaction, right? The naming reaction in Finkelstein reaction, which is a halogen exchange reaction. Here, this CH3I, it will be substituted by this. For example, I think here they should have written CH3Cl or anything else, right? It should not be CH3I because it will definitely form CH3I only in the end, right? So they should have written something else. So this will be CH3I should be the answer. And here in place of this halogen, there can be chlorine, there can be bromine. Anything from bromine and chlorine can be present here, right? But not iodine, right? Okay, and not fluorine. So next part is C. Here it is X, not I. Okay, so now next question is write the equation for the steps in SN1 reaction. Okay, tell me one thing about SN1 reaction. SN1 reactions are two-step reaction. Okay, so SN1 means two-step. One means two-step reaction. Two-step means you will have the formation of carbocation and then you will have the attachment of nucleophile. Right, then you will have the attack of nucleophile. Why it is called SN1 reaction? We will see that in the mechanism itself. See, they are saying that you have tert butyl bromide. Okay, what is tert butyl? When the carbon is connected, see what is tert butyl? Tert butyl is basically this thing. When the carbon is connected to 3 methyl groups, right? And that carbon only is connected to the bromine. Right, and that carbon is connected to the bromine. As you can see here, this is your tert butyl. Right, this is your tert butyl bromide. Now, you have to eliminate Br with the help of SN1 reaction here. Right, okay. So, let us see, you have to make it alcohol. That means here instead of Br there should be attachment of OH. That means the nucleophile is going to be OH here, right? So you can use KOH, right? So now here the first step, this is the first step. In the first step, what will happen? You will have the formation of carbocation, right? This Br will eliminate along with the electrons and you will have the formation of this carbocation, that is CH3, 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 and this is your positive. We know that tertiary carbocation is stable. That is why we know the stability of carbocation is 3 degree, then you have 2 degree, then you have 1 degree. Because of this much stability of carbocation, they are very happy. They are like, okay, we are in a stable carbocation form, so we can easily donate Br negative, right? So next is this carbocation in the presence of a nucleophile. This nucleophile can attack on either sides, right? It can attack on either sides, either on this side or on that side. It's totally depends on the at that time what will happen, right? So that is why you will have the formation of this product, right? That is your tert butyl alcohol. But this product will be retention and inversion, as there will be attack from the both sides, right? So if attack is from the same side, as we know that from the right side only bromine has left, right? If attack is from the same side, then there is retention. If attack is from the opposite side, then there is inversion of configuration, right? Okay, so now next is, okay, now they have also written why the order of the reaction, because this is the slow step, right? This is a slow step. In slow step, it only depends on the only reactant is your substrate, that this reactant is the only reactant. There is no nucleophile involvement here. That is why it depends on only the concentration of your substrate, right? That is why this particular reaction is called SN1 reaction, right? Okay. Because rate is dependent on only one thing, right? Next is how is phenol manufactured by cumene process? A very, very important question. Very, very important question. Let us see that, right? Very, very important question. First is, this is your cumene. Cumene is nothing but isopropyl benzene, right? Cumene is what? You have this benzene, right? And over this you have isopropyl group, right? Isopropyl group. This can be found by so many ways. For example, I have CH3, CH2, CH2, Cl, right? And this is my anhydrous AlCl3. AlCl3. I know there will be formation of which carbocation? There will be formation of CH3, CH2, CH2 positive carbocation, which we know that this carbocation, this is attached to just one carbon, that is 1 degree. So it will rearrange and it will get converted to 2 degree carbocation, right? Now I have this carbocation. This carbocation will attack on benzene and hence in the end you will have the formation of your cumene. Because they can also ask you from benzene, prepare phenol with the help of cumene. Then you should also know the first process here, right? I don't want you to just mug up the questions that are there in your PYQs. I also want you guys to also understand these all are your PYQs only, right? I also want you guys to be one step ahead of your PYQs, right? Okay, so here it will be, this is your CH and this is CH3 and this is CH3. This is your cumene, or we can say this is isopropyl and benzene, right? They can ask you cumene or isopropyl benzene, right? So I think they will ask you cumene only, right? So cumene in the presence of oxygen, that is your O2, what it will do, the hydrogen, for example, the hydrogen that was present here, the oxygen, two oxygen molecule will come in between here, right? It will be like this. It will be like this. One peroxide linkage will be there, right? So in the next step, what you will write, this will be one peroxide linkage and this is your H. Rest CH3 and CH3 will stay as it is, right? Next is, in acidic medium, if you heat it, what will happen? Now the end products, even the byproduct is important here, right? They can ask you, apart from phenol, which thing is formed? So you cannot ignore the byproduct here, right? So what will happen? This will get placed here and this will form acetone, right? So here you will have a formation of acetone and phenol, right? Okay. So all the things are very important and overall this is a very important reaction. Okay, next is among okay, now the question was, let us see the question. The question was, among alcohols and phenols, which one is more acidic? You have to tell which one is more acidic, right? So alcohol and phenols we are saying, for example, I am saying this is your ROH. Let us take an example of CH3. Okay, CH3OH, and here it is your phenol, right? Here it is your phenol. Now, as you can see, in phenol, there is resonance, right? There is a resonance. The lone pairs are donated. The oxygen lone pairs are donated. Now, I told you that whenever we want to predict the acidic nature of an acid, we know that an acid is something which wants to donate H positive, right? For example, you have your precious notes, you have your precious pocket money, right? Your friend asks you that please give me your pocket money. You will be like, oh, I have to give you my pocket money. I am not stable after giving you my pocket money. Then you will not give the pocket money, right? So if you are very happy after giving the pocket money, you will give the money, right? So same thing. If acid is very happy, that means when after donating H positive, this thing is stable, A negative is stable, then we will say this is a good acid. Then we will say it can easily donate H positive. It will donate H positive only when the resultant carbon ion is stable, right? Okay. So here, can I say, here instead of OH, I should write O negative. Here instead of OH, I should write O negative, right? As you can see here, CH3 is donating the electron. All the alkyl groups, any alkyl group must be there. That alkyl group will have the tendency to donate electron by plus I effect. That is plus inductive effect. Now it is going to donate the electron. Now always remember, whenever I am talking about negative carbon ion, I am talking about stress. If it has a lot of stress, if you have a lot of stress, somebody else is giving you more stress, you'll be like, I don't want you in my life, right? So if you're under stress, someone is taking stress from you, you'll be like, yes, you are perfect, you can come in my life, right? So here it is giving the stress, it is increasing the negative charge. So that is why this will become unstable, and here this is taking away this negative charge, right? It is taking away this lone pair, not even lone pair. Here we will talk about negative charge only. Wait a minute, right? Because this is your phenoxide ion, right? So here what will happen? This is your O negative. What will happen? This negative charge, it will go to this side and to this side. Now this benzene ring is taking out the electrons, the negative charge from this oxygen. So it is making it stable because it is taking away the stress. That is why phenol is more acidic as compared to alcohol, right? Okay, as compared to alcohol, phenol is more acidic. Next is using VBT. Again, a very, very important question. Using VBT, you have to tell the geometry, hybridization, magnetic property of CONH3 6, and this is your plus 3. Now I'll tell you one thing, when you talk about NH3, it is showing a strong field leakage effect. It means NH3 will cause pairing, right? There will be pairing will it happen or not, that you will see according to the ligand, because ligand is a strong field ligand, so pairing will happen here, right? So firstly calculate the oxidation number here. Oxidation number is going to be, let us say this is X. So this is X plus 0. Why 0? Because NH3 is a neutral ligand, right? So equals to plus 3. So X is going to be plus 3 here, right? X is going to be plus 3 here, right? So now that means I have to find the electronic configuration of plus 3, right? That I have to find out. So if I talk about the cobalt only, that is in 27, that is the atomic number is 27, right? So here it will be argon 18, then you have 4s2, it will become 20. We are left with 7 more electrons. It will be filled in 3d7. Now students, always remember, whenever you are taking out the electron, you will take out from 4s first, right? So I want to take out 3 electrons. I will eliminate electrons from 4s first. 2 electrons will be gone. Then after that 1 electron from 3d, so it will become 3d6, right? Okay, and I told you that there will be pairing of electrons. So that means in the 3D, these 6 electrons will get paired up, right? These 6 electrons will get paired up, right? Now let us see the full-fledged diagram here. As you can see, this is your cobalt 3 positive. These 3 electrons got paired up. This is your 3D. As you can see, this is your 3D. Then you have 4s, then you have 4p, right? And the ligands which are donating 1 electron pair, which are donating 2 electrons, right? So what they will do, they need an empty orbital here. So what will happen? The 2 orbitals of this D, 1 of S and 3 of P, they will hybridize and they will form D2sp3 hybridized orbital, where you will have the donation from the ligands, and here I am denoting it by cross, right? So there will be donation of the electrons from the ligands in the empty orbitals. Understood this, right? Okay, so that is why what we are saying, this is D2sp3 hybridization. That means it is inner octahedral complex. You can write it is inner octahedral because the d orbital it is using from the inner orbital, right? Inner octahedral geometry. And is it magnetic? Is it paramagnetic, diamagnetic? There is no unpaired electron. So it is diamagnetic. It is diamagnetic because there is no unpaired electron. Even if it has single unpaired electron, then it will be paramagnetic, right? Okay. Next is identify A and B in the following equation. You have this thing. So see, what you are doing here, you are doing the hydrolysis firstly. You have CH3, right? CH3. What will happen? Acidic hydrolysis will happen. This will be Markovnikov rule will be followed here, right? So because it is acidic hydrolysis, to less number of hydrogens, the OH, the negative part will attach, and to more number of hydrogen, the hydrogen will attach. Because in water you have H positive and you have OH negative. So negative part will attach on the less number of hydrogen, the carbon of that double bond which has less number of hydrogen. That means this carbon, the OH will attach. You will have the formation of this. Next is you are having CrO3. Right, which is a good oxidizing agent, but it's not a very strong oxidizing agent. It's a mild oxidizing agent. It's a mild oxidizing agent, right? That is CrO3. Right, it's a mild oxidizing agent. So it will convert this CrO3, it will convert this into CH3C double bond O, and this is your CH3. That is, you will have the formation of acetone here, right? The end product will be acetone. Next is, what is Lucas reagent? What is Lucas reagent, everybody? Lucas reagent is ZnCl2 plus HCl, right? This we have discussed that it will be used to distinguish between the 1 degree, 2 degree and 3 degree alcohol, right? So basically if you talk about 1 degree alcohol, right, it will not show turbidity even after heating, cloudiness. 2 degree alcohol will show after 5 minutes, but 3 degree alcohol will immediately show the turbidity, that is your cloudiness. That is how we distinguish 1 degree, 2 degree and 3 degree alcohols, right? Next is the electron potential. Now very important question, the electron potential for Daniell cell is given below. That means E0 cell is given to be 1.1 volt, right? Write overall cell reaction and calculate the standard Gibbs energy for the reaction. Now you have to calculate the standard Gibbs energy for this reaction. Very simple it is. Let us see, right? So here basically you just have to use this formula, that is your delta G naught equals to minus NF E0 cell. That's it, right? So if you talk about E0 cell, that is given to you, that is 1.1. What is F? F is Faraday, that is 96500, that is approximate value, right? Here they have taken the exact value. I would say just learn the approximate value, that is 96500, right? And what about this N, ma'am? How they calculated it to be 2? See, the reaction is, it is going from Zn, right? So this is going from Zn to Zn2 positive, right? And here it is going from Cu2 positive to Cu, right? As you can see, how many electrons are exchanged. In Zn to Zn2 positive, there is increase in oxidation number, that means oxidation is happening. Here there is decrease in oxidation number, right? That means it is plus 2 to 0, right? There is decrement of a number. So that means a reduction is happening here. That means, can I say here the change is 2. Plus 2 to 0, the change is 2, right? Okay, so here it will be 2. Here the change is 0 to plus 2, again the change is 2. So here that means 2 electrons are gained. Here 2 electrons are lost. So that means the number of electron gained and lost, that will be your N. So N is equals to 2, right? N is equals to 2. Okay. Now, next is mention any two factors which affects the conductivity of electrolytic solution. Students, these all are your last 10 years PYQs, right? Okay, which I find that they are very interesting. That's why I have taken these, right? So, in the end, there is a very surprising question for you that you are totally, it's like a puzzle. You are going to love it, right? So, mention any two factors which affects the conductivity of the electrolytic solution. So, conductivity is affected by, first thing is nature of the electrolyte, that depends on the nature of the electrolyte, weak, strong, what kind of electrolyte it is, what is the degree of dissociation of that electrolyte. Then there is temperature of the solution. It will depend on which temperature it is, right? Okay. Now, next is how benzene is converted to benzaldehyde by Gattermann-Koch reaction. Again, a very important naming reaction, right? Gattermann reaction is different. Gattermann-Koch reaction is different. Just remember this by Koch, K-O-C-H. Now, from this only I will tell you what is the hint. O-C-H, right? So, you can write it by C-H-O. And what is CHO? That's a trick. I know organic chemistry, inorganic chemistry, they're quite difficult to learn. That's why we have these simple tricks for you, right? So this is CHO. That means this thing, this where you have nothing, that will be replaced by your CHO group, right? Okay. And what will be used here? Carbon monoxide and HCl will be used here. You know, I'll tell you one very simple thing, right? So that you will never forget this reaction. How? This is basically nothing but Friedel-Crafts alkylation only. Or you can say Friedel-Crafts acylation only. Because here what we are attaching is, this is your HC double bond OCl. We needed this thing, right? Because in Friedel-Crafts acylation, we use CH3, C double bond OCl. This we can use in Friedel-Crafts acylation reactions, right? That is CH3, COCl. So, everything else is same. Either you can use anhydrous AlCl3. It's not an analog, it's anhydrous. Anhydrous, right? Anhydrous AlCl3, right? Or CuCl you can use here, right? So very important thing is, because this formyl chloride is not a stable compound. This is not stable, right? This has to be freshly prepared, right? That is why we cannot directly apply Friedel-Crafts acylation here. That is the reason I am using CO plus HCl, which will, in the reaction, it will form this formyl chloride, and then that will react, that will attack over there, and you will have the formation, because from here the electrophile generation will be this thing, right? And it will attack over here, and you will have the formation of benzaldehyde, right? That is just a concept that I wanted to tell you before this, right? Okay. Next is complete and name the following reaction. You have to complete and name the following reaction. Okay, so you have this reaction, C double bond O in presence of Zn zinc amalgam, ZnHg, and in acidic condition. So students, this is called Clemmensen reduction. Clemmensen reduction. So what happened in Clemmensen reduction? War was going on, everything was very acidic. Acidic is when there is war going on, right? So war was going on, thing was very acidic. So what happened? Everything ruined, everything gets ruined in war, right? So this oxygen is a positive thing, oxidation, right? Reduction will happen, that's a bad thing. In acidic condition, war is going on, oxygen double bond O is getting converted to your hydrogen, two hydrogens. Now, how to remember the reagents? You can remember this by Jung Hogi. Okay, or you can remember this by any other thing, right? So that is totally your choice. ZnHg, that is your zinc amalgam. In presence of zinc amalgam, Hg means mercury, so we call it zinc amalgam. There will be reduction, and that is called Clemmensen reduction. Okay, they can also ask you Wolff-Kishner reduction. Wolff-Kishner reduction, thus the reagent will change. In Wolff-Kishner reduction, the reagent will be hydrazine in presence of basic condition or ethylene glycol, right? KOH and ethylene glycol. And ethylene glycol. That is your Wolff-Kishner reduction. Okay, everything else will be same, right? This is Clemmensen and this is Wolff-Kishner. And this is Wolff-Kishner, this is Clemmensen. Everything else will be same. The products are going to be same. This is acidic, this is basic condition, right? Next is, what is the effect of electron withdrawing group on the carboxylic acid, right? So for example, I talk about this carboxylic acid, COOH. What I told you about acids, don't see the acid, see the carbon ion formed after it. Now I know that what will happen basically, what is the effect of electron withdrawing group. For example, I have this, for example, I have this CH, for example, I am making this is CH2 and this is your NO2, that is a electron withdrawing group. So if any electron withdrawing group is attached here, what will happen? It will take out the electron. I told you, when someone is taking stress from you, you will be more stable. Negative is stress, positive is not stress, positive is money. Here we are talking about negative, right? So negative, carbon ion is stress. If someone is taking away stress from you, you will be more stable, right? So this means this will be more stable, and hence whenever you will have electron withdrawing group, the acidity will increase, right? What you can write, the acidity will increase, right? Okay, acidity will increase. Next question is, now they have given you this particular reaction, right? You have to answer all of them. So first is your H2PdSO4. Basically this is Lindlar's catalyst. This is Lindlar's catalyst, right? So this is also used for conversion of alkyne to alkene, right? This is also used for that method, right? So Lindlar's catalyst will convert this CuCl to CHO, because this Cl will be converted to hydrogen, right? So this will be C double bond O, and this is your S, that is benzaldehyde will be formed. Now this is the very simple question, right? So now basically what you have to do here, take out this H2, take out this oxygen, right? Take out these two things, attach all of them, right? So this is your, for example, I am drawing it like this, right? I'm drawing it like this, right? So let us see here. This is your C, this is your C, this is CH3, this is CH3, right? I told you keep the double bond also intact. Double bond is also intact, right? Take out this oxygen, take out this hydrogen, right? And attach nitrogen, and this is your OH, right? This is the product that will be formed, right? Okay. Second question also done and dusted. Third is when you have CHO, now there is nitration, right? You'll have nitration. I told you in the first lecture of most repeated questions, I'll repeat it again, that students, for example, you have a benzene, right, to which that group is attached which has lone pair of electrons, right? So it will donate the electron and it will cause plus M effect, and plus M is always ortho para directing towards the electrophilic substitution reaction, right? If you talk about that, in that benzene you have the attachment of that group which is further double bondedly attached to that, where X is more electronegative than G. What will happen here? It will take out this pi bond, it will take out this pi bond, it will show minus M effect, and that is your meta directing, right? That is your meta directing. So now if you talk about this CHO group, we know that this CHO group, if you want to talk about this CHO group, now tell me, will that be meta or will that be para directing, right? Answer it in the comment section. So if you see this, here is your C double bond O, this is your H, and this is your benzene ring, right? We all know that here what we can see, that this oxygen is more electronegative. So, and this is double bondedly connected to this carbon, which is further connected to this benzene ring directly. So that means this condition is followed. The electrons will jump here, it will jump here. It will show minus M effect. That means it is going to show meta directing, right? It is going to be meta directing. So from here at the meta position, this is your ortho, this is meta, this is para. This is ortho, this is meta, this is para. So any meta position, there will be substitution. So for example, I am writing it here, what kind of substitution will be there, right? So let us write the product here. Meta substituted product will be formed, right? Okay. So this is your CHO, this is CHO, right? All the double bonds will be there, right? Meta position is, you can attach it here or here, that's totally your choice, right? Okay. So here I will attach the NO2 group, right? That is your electrophile I will attach here, right? Okay, students. Now, next is out of the following, the coordination entities. So you have two coordination entities, this and this, which is chiral. Draw the structure of its enantiomers. So now let us see this. Firstly, they are saying which of the following coordination entity, this and this, which is chiral, optically active. So cis is your optically active. Let us see the reason. Let us see the diagram here. So cis is basically, cis means sisters. Sisters are always sitting next to each other, right? Love of sisters, right? So sisters are like, means sister means same group will be sitting next to each other. Trans is opposition, right? They are sitting opposite to each other. Trans means, in trans you will have this kind of thing, right? In trans you will have, this is your PT, right? This is 1, 2, 3, 4, 5, 6, and in trans this is your Cl, this is your Cl, this is your En, this is your En, right? This will become your trans, right? We know that if we make a if we make a mirror image of that, that will be same and it will be superimposed with each other. If you make a mirror image of this, that will be same, right? So that will be same only, right? So that is a superimposable mirror image. That means they are identical. Trans are identical, right? So that is why they are not optically active, right? We need non-superimposable mirror image here. So if you talk about this cis, right? These are cis, right? So here This is your dextro that is defined experimentally. If you draw it here, you take the mirror image, you try to superimpose these things. It is non-superimposable mirror image. That means yes, they are enantiomers, they are optically active in nature. Next is structure of its enantiomers. As you can see, when two mirror images, they are non-superimposable, they are called enantiomers. One is dextro, that is positive, other is levo, that means it will rotate the plane polarized light towards the left. It will rotate towards the right side, right? Okay. Now, draw the energy level diagram for the octahedral species. Now, that is simple, right? Let us see how to draw the energy level diagram. That is CFT, crystal field splitting theory. Firstly, what will happen? All the orbitals of D will be degenerate, right? So, this is your 1, 2, 3, 4, 5, right? All the 5 orbitals of your D orbit, all the 5 orbital of your D subshell, that is going to be degenerate, right? So this is your d orbitals. How many how many it has? Dxy, dyz, dzx, dx square minus y square, dz square. 5 orbitals, right? Now what will happen? For example, you 5 friends are sitting like very fun, right? What will happen? Suddenly someone will come in your life, right? And you friends, 5 friends will be like, okay, you'll fight with each other for that particular person, right? So now all of them will have high energy, but still they are friends. But suddenly, to impress the other person, these 5 friends, they got split, right? So what will happen here in octahedral? 2 are above and 3 are below, right? 3 are below. Okay, in octahedral species, dx square minus y square, I am writing it here, and dz square, it will increase the energy of dx square. Why? Because these are along the axis, and your octahedral is also along the axis. If you see the octahedral is also along the axis. This is the axis. In octahedral, the ligands are along the axis, and in this dx square minus y square, if this is the axis, the lobes are along the axis. So there will be repulsion. That is why here the energy will increase. But with dxy, dyz and dzx, they are between the axis. Octahedral is along the axis, they are between the axis, so there will be no repulsion. That is why their energy will decrease, right? And this point here, this is called the barycenter, right? This is called barycenter. From barycenter to that, Eg. Now what is G? G for symmetry, that is gyrate, right? G for symmetry, that is gyrate. In tetrahedral, you will write 3 above, 2 below, and there will be no G, right? There is no symmetry in tetrahedral, right? Okay, so this is your plus, the energy difference is plus 3 by 5 delta O. This is minus 2 by 5 delta O, where delta O is the crystal field splitting energy in octahedral complexes, right? Okay, students. Now, last question, and a very, very beautiful question in front of your screen. Let us see that. An organic compound. This is a very interesting question, right? Okay. So, an organic compound A having molecular formula. Let us see, it has some molecular formula, right? Gives a white precipitate with aqueous Br2, right? So from here I can get whenever there is white precipitate with the Br2, that means the hint is that there must be phenol, right? They have given you hint in the first question itself, right? There must be phenol, because when phenol reacts with Br2, it is going to give us white precipitates of tribromo, right? Tri that is 2, 1, 2, 3, 2, 4, 2, 4, 5, right? 2, 4, 5 tribromo phenol. That is your white precipitate, right? This will give your white precipitate, right? So I can see that this A thing that they have given me, an organic compound A, this is nothing but this is your phenol. This is nothing but this is your phenol. Now they are saying when A is treated with NaOH, compound B is formed, okay? A is treated with NaOH, A will be treated with NaOH, phenoxide ion, sodium phenoxide will be formed, right? So basically this will be sodium phenoxide will be formed. Now this is ONA. Again they are saying that On treatment with CO2 at 400 Kelvin under pressure, whenever these kind of things are given, now understand one thing, there must be some naming reaction over there, right? Only then they give you all these A, B, C, D, identify this and that, when there is some naming reaction must be involved there, right? So here, as you can see, CO2 at 400 Kelvin under pressure followed by acidification give compound C. So basically here what is happening, in the presence of CO2, Cole's reaction is happening here at 400 Kelvin temperature. It will form your salicylic acid, right? This is your OH and this is your COH. Salicylic acid will be formed, right? Then C with react with acetyl. Now they are saying basically this was your A, this was your A, this was your A, right? This was your B and this was your C. Now they are saying that C, it reacts with which thing? C reacts with acetyl chloride in acid. Wait a minute, C is it they are saying, followed by acidic compound C, which reacts with acetyl chloride in acidic medium to form D, which is a popular painkiller. Okay, I think they are talking about aspirin, because that is the only compound that is a painkiller and that is in your syllabus, right? So deduce the structure. Okay, so here you have acetyl chloride that will be substituted in this case, right? So from C you will have the formation of, wait a minute, yeah. So here let us see, from this OHCOH, aspirin is formed, right? So aspirin you have to form here. So basically from this side you have CH3 acetyl chloride, right? CH3 C double bond OCl, right? So here this will be replaced by, H will be replaced by this. This COH will remain as it is. This is OCOCH3, right? Because this H positive, this is negative, it will be replaced by, this is your positive, this is your negative, right? So this CH3CO will replace this H positive and you will have the formation of OCOCH3CH. That is called your aspirin. Aspirin, that is your very popular painkiller, right? So from aspirin only you can get that. They have given you so many hints. One hint is this white precipitate. Second hint is your CO2, Cole's reaction. Third hint is your aspirin, right? And they asked you to identify all of them. So this is your D, right? This is your D, right? Okay, so as you can see, first is phenol, then you have sodium phenoxide, then you have 2-hydroxy, that is salicylic acid, and D is your aspirin. That is a very popular, this should be CH3, it's a very popular painkiller, right? So guys, that was about today's lecture. I hope so that you have enjoyed today's lecture. If you want me to take up more such questions, if you want me to take up organic chemistry specifically, inorganic chemistry specifically, and physical chemistry specifically, then write it down in the comment section. What is the thing, what is the chapter that you guys are finding difficult? So I'm waiting for your comments in the comment section. And if you like this video, don't forget to like, hit the like button and share this among your friends, on your WhatsApp status, on your group, so that we can spread this knowledge everywhere and we can also help someone. Okay guys, then bye bye, take care, see you all in the next session.